So it's all about interpreting the key parts of these graphs. So we have positive, negative, increasing, decreasing, and some end behavior. We're more so focusing on the first four things. So a function is positive where the graph lies above the x-axis. So everything above this x-axis here, all above here is considered positive. Down here is negative. Not too crazy. Okay. Then we go to increasing or decreasing on intervals. So this is talking about decreasing. The slope is what? The slope is decreasing, so it is negative. Someone was going down this slope, it'd be a negative. So from here to here, it's going downhill. So that's considered decreasing. From this section to here, it's increasing, and then it turns right back around. And then again, it starts to decrease. So we'll identify those little intervals. Right? The next part is talking about minimum and maximum. However, so the highest point I see is here, but it has arrows on it, so it's going to keep going up forever. So I cannot technically find the highest point on this graph. So we can talk about a relative maximum, where our graph has its turning around point and its highest point in that turnaround. So where my pen is pointing is considered our relative maximum because we have more arrows going up. Same thing with that relative minimum. We'll throw this into examples here in a minute. Okay, and end behavior, don't stress over this one, but it's talking about what's happening on the ends of our graphs. Okay, and on the left side, as x is going to the left, so it's decreasing, our graph is going up, so it's increasing. So basically, when I go to the left, my graph is going up. When I go to the right, my graph is going down. That's talking about your end behavior. All right, let's go ahead and start with our first example. The first thing I want you to notice is we're looking at the Gateway Arch, the arch in St. Louis. Okay, think about this. If this is the shape of the arch, kind of ignore these points because I don't really know why they're there. I think it was like typo. Think about the arch. Right now it has arrows, meaning it goes down forever. That would mean the arch goes into the earth forever, and then it would shoot back out the other side. Is that realistic? Okay, no. However, it is represented by this equation that just the equation would have arrows. So when we put this into a real world situation, we can make these definite stopping points. So we would be kind of overriding these arrows just for this equation. So trace over those with me. And here's our definite stopping point. The arch may go into the ground a little bit for like a base and stabilization, but for this example, we're going to pretend like it hits the ground, and that is the only level, right? You guys have been in the arch. You can go, I think you go underneath to go in. Yeah, it's pretty cool.
You did it last year.
For school?
Yeah.
Neat. All right, so let's start talking about these other things. First thing I want to determine, is this linear or non-linear? Linear means it's a straight line. Non-linear, so circle that. Okay, so x-intercepts, we're talking where is it touching or hitting the x-axis? Okay, so here's our x-axis. How many times does it hit? 2 times. So we have 2 x-intercepts, and we just write the ordered pairs. So it would be, starting from the origin, left. We're going left 80 times. Each interval is 80. So what's negative 240 minus 80 more? Good. Negative 320, right? And then this number here would be positive 320. Good. So our ordered pairs are going to be left 320 up and down 0. So negative 320, comma 0, and positive 320, comma 0. So 2 x-intercepts. Yeah.
Okay, so that thing that we use in like the brackets and stuff, do you want us to use that here?
We will be using that, but we will be using the interval notation in just a minute here. But these are just strict ordered pairs, so that's why we're using parentheses. These aren't considered interval notation. These are just a point on the graph. That's a good question, though. Okay, so next for our y-intercept, again, our y-axis is increasing by 80 each time. Okay, our y-axis is here, and here is where our arch hits the y-axis. So, good, 640. So that ordered pair would be left and right 0, so 0, comma, 640. Again, an ordered pair, so we'll use parentheses. So that would mean that the height of the arch is 640 feet. Okay, so increasing. This is where we use interval notation, like we did when we did the domain and range. Increasing and decreasing. So I could kind of break this graph into 2 sections from, grab my other color here, from here to the peak, something's happening. Okay, and then from that same point, that peak, to when we hit the ground again, it's changed directions. So in my blue area, are we increasing or decreasing? Increasing. So that will be, I'll just put a plus there to show we're increasing from that section. And so we will measure our x's. So this is all about the domain. So from negative 320 all the way to 0, our graph is increasing, going up. So that will be interval notation. So from negative 320 all the way to 0, we're going uphill. We're decreasing in my red area. Now we're starting to go downhill. Think if there was a person right here, would they be climbing uphill or downhill? And they'd be going down. So this would be our decreasing section. From here to here, if I like separated these, from this point to this point, we are decreasing. So that is 0 all the way to positive 320. So interval notation, including 0 all the way to 320. Question so far? Okay, maximum. We are finding the maximum point. So the very highest point, this again will be an ordered pair. So where's the highest point on our graph? Very top there. It also is the y-intercept. That's not always true. That's just true for this one. So maximum is 0, 640. The minimum, the lowest point. Oops, good call. I wrote the max on the min. If you did that too, hopefully you're using pencil so you can erase. Now let's find the minimum, the lowest point, or points. Okay, if I come up from the bottom, here are my 2 lowest points. They also just happen to be on this one. Are what? Our x-intercepts. Okay, so it does not always happen like that, but this time our max is our y-intercept, our minimum is both of our x-intercepts. Okay, and end behavior is a little bit tricky. I don't want you to spend time stressing over this, but bless you. When we go to the left, when we go towards the left, what's happening to our graph? It's going towards the bottom, or our x-axis. So it's going towards 0 for our y, right? When we go to the right, our graph is going towards 0 again for our y. So when we go to left and right, graph goes to 0. Here's another way we could write that. As x is approaching or going towards negative 320, our y is approaching 0. And on the other side, as x is going towards 320, so as we're going towards this point, our y is then also going towards 0.
Can we write that like in there on the line?
Yeah, whichever one you wanted to use is fine. When you're ready, flip it over.